So many little languages, so little time. I'm Ray Myers. Welcome to Craft versus Cruft. Now, I've been out and about doing some different things, did some conference talks this year, and check out my interview with Emily Bache about test-driven development and AI. That's on the official OpenANS channel. But don't think for a moment I forgot. This is 2025, the year of domain-specific languages. And we're going to finish this off with a bang. We're doing the advent of DSLs right here on Craft versus Cruft. So, no particular number target. Let's knock out as many as we can with some mini-sodes before the end of the year. I have done a lot of exploration on DSLs and compiler technology. Lots of stuff I would love to share with you at some point, but let us cover as many little DSLs, and I'm going to be combining them a bit as we go in some certain way. So let's start with one that's going to be kind of foundational to how we're able to explore other DSLs. Let's look at a DSL for creating DSLs themselves. This is called Langium. I'm not sure if the people at Typefox, which make it, it's part of the Eclipse Foundation, they might call it Langium. I'm not really sure. Comment if you know. Now, this is a tool that makes parsers, sort of similar to Antler in that regard. And it also has some additional facilities to how the trees that the parser creates are constructed, and other niceties. It makes it very easy to make somewhat reasonably featured editor for the languages you create. This is basically kind of a family of tools that make the experience of creating a full-featured DSL better. But the thing that I really like about Langium is it's got this playground that I can quickly go into and very easily iterate on a grammar that I'm building. So it's just very convenient to build with and to show people things in, as I'm doing now. Now, in order to show you Langium, I'm going to have another DSL to show you building with it. So let's go over to the Langium showcase. We're just going to look at the state machine example. If you're not familiar with state machines, they're a marvelously useful way to think about the states that programs or other kinds of processes go through. And as you can see, there's several different states that are defined. In each of those states, there are transitions that this event might happen while in the yellow light state. For instance, the switch capacity event might happen, and it would lead to the power off state. Or another transition that could happen, boost the font a little for you, is the next transition, and it would go to the red light state. And then we've got the transitions that can happen from there. If that's what can happen, we can go next, or we can switch off. You switch back on, next, cycle through these light states. You could imagine any other set of states that your program or machine might go through. State machines are a really useful modeling technique. A related programming design pattern you might be interested to learn about is used in Rust a lot. If you search for Rust and state machine pattern, you'll see what that's talking about. So let's use the state machine DSL to build our own state machine, and then we'll go to representing this state machine DSL in a Langium grammar. Okay? Let's make state machine TDD. And let's say the events, well, we don't know what the events are going to be yet, but the initial state will be red. So we're modeling test-driven development here. And the states will be red and green. Perhaps let's see how that works. Now, what can we do with red and green states? Well, if we're red, we can write a failing test. That would mean if we did that from green, that would take us to red. And we shouldn't do it in any other circumstance. We could also update code to pass, which would take us from red back to green. And what else could you do in TDD? hopefully you're already saying to yourself, you can refactor. And that is done from green and keeps us at green. All right, so let's play around with this. We've modeled the state. Let's see what it looks like. We start out in state red, and we must pass. Now that's actually not true. If we start from no code at all, then I guess we would be starting initial state green, hopefully, right? Already I'm learning my representation was wrong when I start to look at it. That's why modeling tools are useful. First, we write a failing test. Red, green, then refactor, we stay green. So this is a reasonable modeling of an idealized like test-driven development flow. But I notice I hit refactor and nothing happens. It seems kind of unsatisfying. So we could also, equivalently represent our process with a more elaborate set of states if we chose to. We could also say there's a notion of whether things are ugly or not, or unmaintainable, or however you want to call it. I'm just going to call it ugly for this situation. So I'm going to say that when you update code to pass, you go to green ugly state. And then from green ugly, you could refactor to simply green. And then green, you can go to red as per normal. Can we just simply write a failing test from red? What does that mean? Unclear, right? We could model to say you just simply always refactor after red and green. What would that look like? You start at green, write failing test, you update the code to pass, you're at green ugly, then you refactor, you're at not ugly green, and so on and so forth. Now, you could do that. You might also want to make this really just being assess the need for a refactor. And when you update the code to pass, it may or may not require this, right? So you could say that there are events like update code to pass and update code to pass ugly. And one of these goes to green ugly, and the other goes to green. And so now we have this notion that sometimes there is that need, and sometimes there is not. Depending on our needs, we might model it in different ways. All right, so I think you've gotten a feel for how working with this state machine DSL would work. How would we make this state machine DSL? So this is where we go from here to working with the Langium playground. And now the DSL is for the language itself, for the language grammar. This is the Hello World example here. And as you can see, it's just a language that defines some people and then says hello to them. So if you saw the episode on regular expressions before, where I modeled the grammar using the Antler sandbox, this is kind of a similar thing that we're doing here. This is based on BNF notation, which is a common way to represent grammars, and there's a lot of little dialects of it. Langium's got their own. Something that's interesting here is it is saying things about when it's saying model contains, a person or a greeting, and actually that or that, it contains 0 or more of them is the star, remember? It is also putting the persons, is adding them to a person's list and taking each element that matches greeting and adding it to a greetings list. So it's stating things about how the syntax tree will be constructed, which later, like your DSL engine, could use that information, look for it on those fields. So that is a nice convenience that it offers. And if you explode up the syntax tree here, you can see there it is, persons and greetings right there. These three things, you end up looking at them a whole lot as you're developing a DSL grammar, like the grammar itself, the content you're thinking about parsing right now, and then what the tree is. So I really appreciate an interface that brings all these three together. I would like everyone to put that in their tools. Another nicety here, if you look at this tree, it is saying that this person is a reference. There is this notion of references built in to the parsing engine. It's got kind of part of a language engine that it's providing for you. Just by this grammar, it would already know if this weren't a legitimate reference to a person, that it shouldn't be accepted. For example, if we say, hello, Ray, it doesn't take that. It says, I cannot resolve reference to person named Ray. Whereas if we go ahead and define me, then it accepts it. I like that. Hello to you too. Now, this has pros and cons because it is now very convenient to have reference resolution built into the DSL you're creating, but it also is kind of imposing its opinion about how references work. So you may or may not want that for your use case. We are not going to think about references too much for this. I'm just going to define the basic grammar, and we're going to try to parse the state machine DSL. All right? So we want, when we're done, to be able to parse this program. As you can see, it is not being parsed right now. The first element is entry. I will say entry will be like a machine. I'm going to comment out part of this grammar. And for now, I'm just going to put some garbage here. And I'm going to keep other stuff, though. I'm going to keep its notion of an ID. Looks like its ID starts with underscore or lower or uppercase character. And then after the start, it is all of those things plus a number. That's what /W and then an underscore would indicate in this regular expression character class here. So that is a pretty normal way to think of an identifier in a programming language, so I'm going to let that be. And it also has multi-line and single-line comments. I'm going to let those hidden terminals also stay. But the rest of the language, we need to do something different with this. Now, it does not like what I've done here. Data type rules cannot infer a type, so it likes to be able to build a syntax tree. I haven't given it a type that can apply to the node in this tree. That's kind of a quirk of the way Langium works. So I'm just going to assign it to a garbage value. It parses really nothing here, and it creates a useless value. But let's start iterating. I know that to define a state machine, I will need this token here, and then I will need an ID, right? And I'm not just saying there's an ID here, I'm assigning it to something. Okay, so it parsed the first little bit, and then you can see the ID was stored there. And then what? Well, we're going to need to say events, and there'll be some event IDs. So how's that? All right, it has successfully parsed that. After that, we want to be able to say there's an initial state, and then that has an ID as well. So after that, I'm just going to break that out. I'm not thinking too much about the structure of the grammar right now. I just want to get it parsing. But I'll say then I want an initial state, and let's define that. Initial state is simply the token initial state followed by a single ID, right? Which, again, we're going to assign. Do you agree? Semicolon here. And now it's saying, oh, I expected more. That is no longer a good state machine. Good. And now it accepts it. Good. And notice it just bubbled up event IDs to the base node here. we may not want that. We may not want to, sometimes we do, sometimes we don't, right? So it just defaults to conflating them. But I'm going to say I'm going to save to initial, and the structure changes. So then what? Well, then it's a series of states, and each state has got several transitions. So this is what I want to be able to parse next. And I'm going to say after the initial state, you define several states. Might there be none? Might this be a star for 0 or more? We'll say for now that it needs to be 1 or more. And use a plus. So, state looks like that was defined as the token state, then an ID, which we'll save as ID, and then some stuff, and then end. All right? Semicolon. All right, so that part is part of this. Then there's a series of transitions. So we will say that before this, there will be transitions. And is it 0 or more? We could say 0 or more. These are the sorts of things you think about. What are the invariants? Is it valid to have a state with no transitions? Perhaps it is. Perhaps it's a terminal state. Let's make actually singular, and then the plural is kind of implied with that star. And that looks like ID followed by an arrow followed by another ID, right? Now, what is it upset about? Data type rules cannot infer a type, right? So we have to construct this AST node here. AST stands for Abstract Syntax Tree, you may recall. So this is transition from this to that. So I'm going to use from ID to ID, and yeah, and it's parsing now. That's great. So let's see, does this look reasonable, how it's building the tree? States, and then there's a transition, and from this to this, and then the ID is, that's a little weird. The ID is just red when it's really, yeah, the state node and the transition node seem to be sort of tied together, right? So why to do that? Well, we forgot to assign this to something. And I think that ought to be plus equals. There we go. So now we have a state with ID red, and underneath it are these transitions. So I think this tree now looks pretty reasonable. Can this now parse our entire TDD state machine we created a minute ago? Yes. Yes, it can. So this is reasonably full featured for the features of this. We might think about, like, what is a valid program? What do we want to allow or not? Do we want there to be allowed to be no initial state? Perhaps not. But do we want to be able to say this in any order? Right now we've said initial state must come, at this specific point. So what if we do something like that? What if we have multiple state machines in one file, for that matter? Are these things we want our language to allow? These are valid questions. You might answer them either way, but let's just try making this parse. Let's rethink our grammar to support that. Well, the first thing is we must see state machine such and such. Let's say we do want to enforce that that's first. But then one of several things might be okay. It might be okay to say there's these events. It might be okay to say this is the initial state. And it might be okay to say that this is some individual state. So this or that or that. Sometimes people like doing or on the new line. Makes it a little more obvious. Now, then what would we be doing? Do we allow several of these? Now let's see what the tree looks like. So I've got an initial. I've got these states. And I've got my event IDs, and it accepts them in any order. This leaves other issues here, right? Like I might say initial state 2 different times, and this might be allowed. It'll just overwrite the other one. That might be bad. We might not want to allow that. So we might have, post-processing. We might put all these, define something like machine attribute, and put all those in a list and do some post-processing, or, maybe there's something else we can do with the feature set of Langium. But generally, this gets us a lot of the way there, and then we can take this tree and do a lot of useful stuff in code. Anyway, that's a brief intro to using a DSL to make other DSLs. In this case with Langium, we could look now, I haven't looked before, and see what their grammar actually looked like and the rest of the utility that created this little demo. Looks like it's over here on GitHub in Eclipse Langium/Langium, and we've got examples, state machine. Looks like source language server state machine.langium is where the grammar itself exists. You can see this is how they chose to define it, and there's also another number of other facilities in here for, how they generate, an editor plugin based on this and neat stuff like that. Well, until next time, comment with the DSLs you'd like to see next in advent of DSLs. I've got a plan, but there's still time to influence it. And as Lao Tzu said in the Tao Te Ching, with patience, the most tangled cord may be undone. Thank you.